Okay folks, MBS here. Let's talk about a subject that not many people know about or understand, and that is, where is your camshaft positioned when you're setting the tappets? Alrighty, everyone knows that, well, nearly everyone knows that the camshaft lifter should be sitting on the base circle of the camshaft somewhere, but where exactly should it be sitting? Now I've got just a rough sketch here of one camshaft lobe, and here you can see the opening and closing ramps of the lobe, and you can see the concentric circle. Now everything from the opening to the closing ramp on the camshaft is considered to be the base circle. Anywhere along there is where you can set your tappets. In other words, if you set your tappets at 20th thou here, it'll be 20th thou there, there and there, all the way to almost the opening or closing ramp, depending which way this is rotating. Alright, now that's a fact. That's just the way it is. A lot of people will disagree, but I don't know why they disagree. They obviously know something I don't, but it doesn't matter. That is the safe area. But to make the exercise even safer, every method I'm going to show you here on where to position your camshaft, we're going to keep it above the 180 degree line here that's drawn through the axis of the camshaft. Okay, so everything on that side is considered ultra safe. Alright, so we can put big cams in it, little cams, it doesn't matter. We're never going to adjust the tappets in this area. Alrighty, so what we're going to be discussing are the four common methods that are used these days, and that's the follow the distributor rotor around, overlap on the valves method, the ICEO method, and the top dead center method. That's the way I'll discuss it in that order. And I'll put a timesheet up here in case you're not interested in some of those methods, looking at them at all. So I'll put down the time that you can skip to get to the section that interests you more. So having said that, you know where we're going to, area we're going to use on the camshaft for tappet adjustment. Alright, you've seen this one before maybe, you saw me draw it up in a little exercise I did. A performance camshaft, 300 degree duration, this one happens to be. I've actually got another one that I was going to use. This is a 330 degree duration camshaft, but I'm not going to use that because not many people are using cams that big. So 300 is not a bad size. Most people use a 280 or 290, but the 300 degree duration camshaft will definitely prove without a shadow of a doubt, when we're setting tappets on the base circle, that it can be done using a fairly wild cam. So let's get stuck into it. I'll show you the top distributor rotor method first. Very easy. Right, with the follow the rotor button around, you must have an engine that's been running and you're just doing a normal service on it because the tappets need adjusting if it's a solid tappet, or you just want to check your hydraulic lifter adjustments. You could use the follow the rotor button. Okay, so you remove the cap off the distributor and have a look at your rotor button and align it with any terminal you like to start with. If you don't want to start at number 1, that's fine. Wherever you start and you point the rotor at a terminal, the camshaft position for that piston will be in this position. Alright, the lifter will be directly opposite both lobes, or not directly opposite the nose, but straight up and down on top dead center. Alright, we call this is not overlapping yet, the overlap is down here, but we are on compression on that cylinder because the rotor is pointing and ready to fire on the cylinder you're pointing it at. That's the camshaft position. Now I've marked on this camshaft that 180 degree line, so from that section there all the way around to here on the inlet valve, and all the way from there to there on the exhaust valve. That's the safe area where we can adjust the tappets. And as you can see, it falls in between on both sides of those lobes in that 70 degree area here, which crosses those two lines, center lines. Now remember, this is a 300-degree duration cam. If this was a baby cam, this angle here would widen up and you'd have a lot more freedom in setting this up. But this is how it is when you set the rotor pointing at a cylinder. If you don't get it pointing directly at a cylinder, it doesn't matter. If you're 10 degrees out, the camshaft will sit there. If you're 10 degrees the other way, the camshaft will sit there in relation to the lifter. So you can still set the tappets even though you're not directly on the terminal. And that's easy as, isn't it? So you set the tappets there, or you check them, adjust them as necessary, move on to the next cylinder. Crank your engine over till you get to the align the rotor with the next terminal, and this is where the camshaft will be for that cylinder that you're setting. Alright, so that's pretty easy. Easy to follow, no error, and you just continue around and until you get back to the cylinder you started on. Alright? I don't think I have to explain that any further because it's as easy as that. We're on the base circle of both lobes within that 180 degree area that I showed you earlier on that single lobe, and all is honky-dory. Right, moving on to the overlap. Now, what we're talking about there, of course, is getting the valves to both be open at the same time. So what we really need to do now is actually you're going to follow the rockers and see what they're doing, or the valves. Alright, so a little bit more work involved. You have to know which is the inlet, which is the exhaust, so you know what you're looking at. So let's put the cam back here a little bit, and we're cranking it over, and you're seeing this valve closing. That will be the exhaust, but it could be the inlet. You don't know yet until you get to here, and then you'll see the inlet start to open. You know you're on overlap. Exhaust is closing, inlet is just opening, and they're both open at the same time in this position. Obviously you don't set the tappets on this cylinder that you've got it set up at on overlap. You've got to set the tappet on the opposite cylinder. Alright, easy for a 6-cylinder. We know it's number 1 and 6 are at top dead center at the same time. So when number 1 is on overlap, you would set number 6 because the lifter would be sitting on the base circle of the camshaft. Alright, so I have a little pictorial, or a little video on how to check which other cylinder is on top dead center. It's easy for the 4 and 6 cylinder. V8s can be a bit tricky because there's about 7 firing orders. Some of them are most uncommon. There's about 4 common firing orders. So to work out the matching pair, I've got that on a separate little video on my website in Tech Talk, and it's Tech Talk 2, 4 positioning methods of adjusting the camshaft. Alright, so you can go in there and click on the camera icon, and it'll take you to a quick tutorial on how to match up your pairs. So you know the pairs of cylinders that are on overlap and the matching one that's also on top dead center on the compression firing stroke. So we've worked this out. Let's say we've rocked number 1. We're going to set number 6, and we know number 6, the lifter is going to be there on the camshaft. Okay? Easy as. So you set both valves, inlet and exhaust, on that cylinder, just like you did with the following the rotor button. This is the exact same position that the camshaft was in when you put the rotor directly on the terminal, yeah? So it's as easy as. So you just follow the firing order. So if you rocked number 1, 5 would rock next, okay? And you'd set number 2 as per the groupings. Alright, so it's always a pair of cylinders on top dead center at the same time. One is on overlap, the other is on compression firing. Alright, and it's the compression firing cylinder that you want to set because the lifter will be on the base circle of the camshaft of both the inlet and exhaust. Alright, so that's your overlap method explained. Fairly simple, yeah. I don't think you can go much wrong there. This is more suitable for when you're assembling the engine. A lot of people use this method to assemble the engine. Alright, because you obviously haven't got a distributor in there and you can't follow the rotor button. But there are other methods still available to you. And the next one we're going to cover is the ICEO. Now the ICEO, that's the inlet closing. So let's have a look. Here's the inlet. This is the V8, so we're going to turn it that way. So there's the inlet closing, and there's its finish there. It's now on the base circle, all right, of the inlet. Which valve can we set on that cylinder? We can set the exhaust, yeah, because it's opposite the nose of the cam, and some people call that the heel because it's directly opposite the nose or the toe. So a lot of people set it up like this. A lot of work, because you have to turn it over every time you want to do a valve. So you're going to be turning the engine over more than 16 times actually, because now you've got to turn it over so you can set the inlet. So ICEO, exhaust opening. So let's continue on and open up the exhaust. And here we go, exhaust starts to open, and you stop the engine there, and you're going to set the inlet valve on that cylinder now. And that's it, you've done one cylinder. You've had to rotate it twice to get the camshaft in the right position. Alright, this seems to be a very popular method. Personally, I wouldn't use it, not on a V8 or a 4 or a 6. I'd use this method on an odd cylinder engine, like a 5-cylinder, where you don't have another cylinder on top dead center at the same time. I would definitely use this method to make sure that I've got the camshaft in the correct position. Alright, so that explains the ICEO. It's not a hard one to figure out. So if you're a believer that you have to set it on the heel, directly opposite the nose, then that's how you're positioning your camshaft to get it in the right spot so you can set your valves. So there's 3 methods I've covered already fairly quickly to give you an understanding of where the camshaft lobes are so that you can actually set your tappet. Yeah. Right, I've saved the best till last. Alright, the top dead center method. Really, really easy. Now this was always reserved for diesels only, to do 4-6 cylinder diesels. Diesels are hard to crank over, high compressions, so they had to make it a little bit easier to set your tappets, and only requires you to turn the engine twice. You put it on top dead center, you set half your valves, and once they're done, you rotate it 360 degrees, put it back on top dead center, which will then be compression on a different cylinder, and you set the remaining valves. Alright, so I've got a table, as I said earlier, on my website that shows you all the valves you need to adjust when you're on a specific top dead center. I'm going to try and explain this as best I can, because it is quite a complex operation to work all this out. But if you follow everything on my website, that little table, which I'm going to show up on top of the screen shortly, we're going to do a Chevrolet V8 using the top dead center method, and you're going to be able to see that even with a big cam like this, you're going to be able to set your tappets using the top dead center method. And this would be absolutely ideal for engine rebuilders to set the tappets like this. Don't have to muck around turning, cranking engines over all the time, 90 degrees at a time, setting your lifters, whatever you're doing, whether it's solid or hydraulic. You can just put it on top dead center and use this method. Alright, so let's see if I can explain this properly to you. And we'll zoom in on this now and we'll start yakking away and tell you what I'm up to. Now, using the top dead center method, it does not matter whether it's a 4-cylinder, 6-cylinder, 8-cylinder, a flat 6, you know, even a flat 8, if there's such a thing even exists, it doesn't matter. What we're looking at, or a V, okay, most V8s are V, yeah, that's why they're called V8s. That lifter is in relationship to the camshaft. I know that you're going to have your lifter out here at 45 degrees and a lifter out there, but disregard that because we're looking at the lifter bore and lifter in relationship to the camshaft. Alright, so this keeps it simple and you can see it as it is directly while the lifter's sitting on top here. So when we put it on top dead center, it's going to be a a long chance that you're actually going to have it on top dead centre to start with. You're going to have to crank the engine over and put it on top dead centre. It would pay to see what your valves are doing, okay, so you know which cylinder is on compression. So if you're looking at number 1 cylinder, or it's matching one that's on top dead centre, in a Chevrolet that would be number 6. So you're looking at number 6 cylinder and number 1 cylinder for valve movement, so you can tell which one's on overlap and which one is going to be compression. So let us say that we are on compression number 1. So we just saw number 6 on overlap, yeah? Exhaust closing, inlet opening. Okay, so this is where the camshaft is sitting right now on number 1, top dead centre, compression. So we can set both valves, yeah? They're both on the base circle, behind that 180 degree line. So you can do both the inlet and exhaust on number 1. Easy as. So how do we work out all the others? Well, every 90 degrees there's a firing stroke, yeah, in a V8. So in a camshaft that would be halved to 45 degrees. So I've got 45 marked here. So what we're going to do is we're going to have to go backwards to work out where is the camshaft on the next cylinder that fires, which is number 8. And it will be right there. That's where the lifter will be on the number 8 cylinder camshaft lobes. Alright, when we're on top dead centre, compression number 1. Now we're not going to turn the engine over anymore until we've set all these valves that can be set while it's sitting at top dead centre, compression number 1. So we haven't turned the engine over at all, we're just looking at where is the camshaft in the relative position to the lifter, and that's where number 8 is right now when number 1 is on compression. So what valve can we actually set here? Well, we can't set the inlet. We are within that 180 degree safe, unsafe area, but we know if we've got a baby cam we possibly could do that one. But I said we're going to stick with the 180 degrees, 90 degrees either side of the lobe, the safe, total safe area. We're going to set the tappet on. So you can see you can set the exhaust valve on number 8. Yeah? Easy as. So you set the exhaust or you check it if it's okay, it doesn't matter, you adjust it as necessary. Next one in the firing order is number 4. So number 4, the camshaft is going to be positioned like that in relation to its lifter. So which valve can we adjust here? Exhaust again. So number 4 exhaust, we can set it. Then we're going to go have a look at number 3. Where's number 3 camshaft in relation? Hey, look at that. We can set the exhaust again. Now we're starting to get close to the 180 line, but we've still got quite a bit to play with there. So we set the exhaust. So obviously the opposite cylinder to number 1, which is 6 overlap, we know it's on overlap because it's the other cylinder that's on top dead centre while number 1 is on compression. We can't do the valves. Okay, they're both open here at the same time, what we call the overlap. So we go back another one, and that'll be 5. We can no longer set the exhaust valve, but we can set the inlet. It's on that 180 degree portion, so we would set 5 inlet, and then the next one in the firing order would be 7, so we would set the inlet, and then number 2 we would again set the inlet. That's pretty close to the ICEO, isn't it? Very close to being on the heel of the cam. So when we come back to top dead centre again, we're back at number 1 compression, and we've already done those so we don't have to worry about it. So that's where the camshaft is in relation to all the cylinders that are on their different strokes, and we know where the camshaft is for every one of them. Now we've got to set the other half, yeah? So what we do is we rotate the engine now 360 degrees so that we're on compression number 6. And this is where the camshaft will be when we're on compression number 6 after we've rotated it 360 degrees. So what's after number 6? It'll be number 5. So we'll go to number 5. What valve can we set now? We can set the exhaust, because we've already set the inlet earlier when it was on top dead center compression number 1. Then we go next one in the firing order after 6, that's 6, 5, 7. We can set the exhaust. Pretty good, eh? Number 2, we can set the exhaust, still on that safe portion. Alright, then we've come to the overlap of number 1. So we've already set number 1 right at the very start, so it's on overlap now. We can't bother doing anything with that. Then we go to number 8, and what can we set there? We can set 8 inlet now. Then we go to number 4, and we can set the inlet valve. And then we go to number 3, and we can set the inlet valve again. Alright, and then we're back to the top dead center, which we've already done. Number 6, we do the inlet exhaust, which we've done. Alright, and that is the top dead center method using a high performance camshaft, and you can see it easily done. It does not come anywhere near the opening and closing ramps of the lobes, because we've stuck to the 180-degree safe portion of the camshaft base circle, which is ground concentric. And I keep harping on that word concentric because that's exactly what it is. The camshaft spins around that axis, and so the distance or the radius of that camshaft is the same all the way around, even a little bit further until it gets to the opening and closing ramps of the lobes. As I said earlier, we're not going to worry about that little section. We're going to stick to the safe part, the 180-degree section. Alright, so that's the top dead center method on a V8 with a high performance camshaft. Oh, I bet you that blew some of yous away. What did you think of that last one? Pretty cool, eh? I thought it was when I first discovered it many years ago. I wish I could only have done it at least once in my life, that method. But, oh well, that's the way things go. I was not going to say shit. Anyway, on my website, there's the tables. I've got 7 firing orders up there, including the 4-7 swap for the chef. And the blue section of the table, as you saw across the screen, hopefully I got it up there, you could see that table. When you put it on top dead center compression number 1, it tells you all the valves you can adjust. Okay? When you've adjusted all of those and rotated it around 360 degrees, and you're in the pink orange section, you're now on top dead center compression number 6, and then you could adjust all the valves that are written in orange there. I made it really simple for you, and I worked all those out using a camshaft like that. Well, I didn't actually use that one, I used the 330 degree one when I did this. So perfectly safe. Which method you use at the end of the day will depend how hard it is to crank the engine over, your accessibility to the crankshaft pulley or your belts and everything, because sometimes you don't have a bolt at the front. You may have to put 3 bolts in the harmonic balancer and put a screwdriver in there. Various ways that you would use. Some people put them in gear, nudge the car, and that turns the engine over bit by bit. Many ways to get your engine over to where you need to get that pulley so that you can set your tappets. Alright, so pick a method, any method, they all work. Some have got for and some have got an against, but oh well, the one that I use the least would be the ICEO. I've used it twice. Before apprenticeship, because some guy showed me that my mother knew or whatever through relations, before I was even interested in being a mechanic. He used that method, and I still remember it, and my boss showed me once, and he said, don't ever use that. Just his advice. Here are all the other ways you can do it. Alright, so we've mainly used the overlap method, and diesels we've used the top dead center method. Alright, and occasionally I've used the rotor method. Alright, so take your pick, whatever you like to do. I've shown you all the 4 methods. You pick which one you like, which one seems to be the least amount of work, which one's easiest to do for your particular engine. Alright, so I think I've covered all that, and please read my article, because It's basically a text article with all this stuff written down there for you. You're going to have to come here anyway to copy down these valves, unless you want to make your own camshaft like I did and work it out all for yourself. Alright, it's great fun. Alright, I hope you enjoyed the video and we'll catch you next time.